Today we're going to talk about unit rate and constant of proportionality. Some of this should be reviewed from last year. The first definition we're going to look at is unit rate. Unit rate is going to be a rate in which we compare a quantity to one. So a unit rate is helping us figure out how much of something happens the first time. So maybe how much does 1 pound of apples equal? Or how many miles can we run in 1 minute? So when we are comparing something to the first value. Our second definition is going to be proportion. A proportion is going to be a statement of equality. So when two ratios are equal. So we usually set up proportions to find missing values. Our next definition is going to be constant of proportionality. So this is going to be a unit rate associated with different pairs of measurements. And so we're going to see this constant of proportionality in proportions. And it's going to be very similar to a unit rate. So a lot of times you may see these used interchangeably. So let's look at our first example on your guided notes. This graph shows Raymond's results for the 50-meter dash and how fast he went, or not how fast, but in how many seconds it took him to run a certain number of meters. So number 1 says, what does the shape of the graph tell you about Raymond's speed during the race? So if we look at it, it shows that his speed was constant. And that is important because we're talking about a constant of proportionality. So number 2 says, explain how you can use the graph to find the unit rate for Raymond's speed. So if you look right here, that's going to tell us when he went 1, he went 5. Mine is a little messed up on my screen, but if you look at your guided notes paper, it shows you that when he had ran 1 second, he had went 5 meters. So this unit rate is going to be for every 1 second, he's going to go 5 meters. If you look at the next part, part B, it says Angel's data during the race can be described using the equation y equals 4.5x. Explain how you can find the unit rate for Angel's speed from the equation. If you look back at the top of our paper, it talks to us about this formula y equals kx. And k is going to represent the constant or our unit rate. So if you look at this equation right here, 4.5 is going to be the unit rate for Angel's speed. Let's look at part C. Carlos ran the race at a constant speed. The table shows the distance Carlos traveled during different times in the race. Part 1 says to plot the data on the graph. So our first value is going to be 2 and 9.5. So here's 2, and we're going to go right under 10, so 9.5. Our next one is going to be 4 and 19, so here's 4. We're going to go right under 20. Now we can look back at 6 and 28.5. It's going to go right under 30. And then we'll do the last one, 8 and 38. We're going to go right under 40. And you can see we get a straight line, showing that, our points aren't going to be exact, but they are pretty constant. So it says, how can you use the graph to find the unit rate for Carlos's speed? So we want to know, where is he at when he is 1? So right here, when he has only gone 1 second, where is he going to go? So we can estimate that if you look at our graph, it's going to be under 5. But if you want to know exactly, we have a ratio of 2 to 9.5. Now, in order to get that to equal to 1, we're going to divide both of them by 2. And we're going to say 2 divided by 2 is 1. And 9.5 divided by 2 is 4.75. So our estimate of under 5 for his unit rate is going to be correct, because his unit rate is going to be 4.75 meters per second. So we want to figure out who won the race. Did Carlos win the race, or did Angel win the race? If we remember, if you look up, Angel's unit rate was 4.5. So for every second she runs, she goes 4.5 meters. For every second Carlos runs, he goes 4.75. So Carlos is going to win the race because his unit rate, or constant of proportionality, is larger. Let's look at this last one. Suppose Raymond's twin brother, Ricardo, also runs in the race. Raymond gives Ricardo a 10-meter head start in the race, and they run at the same speed. The graph below shows the results. So you can look on your paper to see your graph. And we're going to write an equation to represent Raymond's position. And remember, we're going to use that y equals kx, where k is going to be our unit rate. So when Raymond has gone 1 second, what is his distance in meters going to be? And if we look on our graph, it's going to be 5. So it's going to be y equals 5k. So if we look at number 2, what do the points 0, 0 and 0, 10 on the graph represent? That's going to represent where they were before they had started running. Number 3, are the lines parallel? We would say yes, they are parallel, because one, we can look at them and see that they are never going to intersect. But they said that they ran at the same speed up here. So if they're running at the same speed, they're going to increase their miles at the same, or meters, sorry, not miles, at the same rate. So yes, they are. Ricardo runs at a constant rate of 5 meters per second and has a head start of 10 meters. Write an equation of the line that represents Ricardo. So we already said that the constant is going to be 5. So we have y equals 5x. But he has 10 more than starting at 0. So we need to add 10. So now we need to look at number 5 and says, what is the unit rate for Raymond? Well, we can look at our equation. For Raymond, remember it's going to be in that case, so Raymond is going to be 5. And now we can look at Ricardo. His is also going to be 5. So compare and make a statement. What do you think? We're seeing that they're going to run at the same pace. So since they're always running at the same pace, no one is getting faster, no one is getting slower, Ricardo is definitely going to win because he started 10 meters ahead of Raymond. So I want you to work with your Google assessment and try and just solve 2 of these problems they don't have graphs. But I do want you to try them and see if you can solve and figure out what is the unit rate or the constant of proportionality that's asking you for. Tomorrow in class, we'll look at some more problems with graphs. But go ahead and write down your answers and all your work for your Google assessments, and we will go over them tomorrow.